Okay, this is the second part of nonlinear graphs, answering every exam question that's been done. Like I've said before, if you do want to use this document, it's always linked in the description. So I've done all of the quadratics. I'm now going to do the cubics, exponentials, and then I'm going to look at different types of graphs that there are as well. Okay, so I'm going to go to the cubic section. And I've shown this in the previous video, but what you can do here is you can actually calculate these table of values by putting them into your calculator. So just as a reminder how you do that, when you're on the normal mode, you go mode and then table, and you just type it in like a normal kind of graph that we've got here. So I'm going to type 5 minus, press alpha to get the red letters, 5 minus x cubed, so I'm going to do x to the power of 3, and it's going between minus 2 and 2. If it says g of x, just press equals to move on to the next bit. So I'm going to start at minus 2, I'm going to end at 2, and I want to go up in ones. It fills in the whole table for you, so we get 13, 6, 5, 4, and minus 3. So we're going to draw this in. We're going to have our minus 2 goes with 13, which is up here. Minus 1 goes with 6, 0 goes with 5, 1 goes with 4, and 2 goes with minus 3. So it's a cubic shape, which means it's going to have this kind of like wiggle in the middle like that. Now I find these way harder to do on the iPad than I do in paper. So sorry that these aren't the most accurately drawn, but you'd still get the marks for what I've done there. And you can see we've got the correct values, and the correct graph means that it's drawn smoothly, okay? So now we're going to look at some other kinds of ones. It says, on the grid, sketch the curve with equation y equals 2 to the power of x. Give the coordinates of any points of intersection with the axes. Well, this is a type of exponential graph. We can see that it is exponential because the x is in the power. Now, exponential graphs start off really small, and then suddenly they just come up. Let's do this even better. They come up and then they got really fast like that. This is absolutely atrocious. Let's neaten that last part. I want that to be like a nice kind of smooth curve like this. And it does say give the coordinates of any points of intersections with the axis. So this point that we've got here, that is when x is equal to 0. So when x is equal to 0, we would say that y is equal to 2 to the power of 0. You can check it on a calculator, but it's just 1. So that point that we've got there is 1. Okay, and because it did say coordinates, I'm actually going to say that the x coordinate is 0 and the y coordinate is 1. And you can see this is what the graph looks like. It doesn't need to touch it down here, it's perfectly fine. It does say condone touching the x-axis, but I don't think it should do. I think it should just be like a little bit above it. But they let you have it. If you do that in A level though, they wouldn't let you do that. Okay, now we're just going to do some graph matching that we've got for these ones that we have here. So I think we can probably do this one down here. This is the exponential graph. I think we can do that because we've literally just answered it. So we can say that that one is going to be graph A. And then we have got a sine x graph. Now the sine x graph, this one is the cos because it starts here at 1. This is the sine graph because it starts at 0. So it's going to be C. And then I think the next easiest one is this reciprocal graph, okay? This reciprocal graph, we've got a choice between B and H. Now, the reason it's going to be H is because it's a positive 4 in the numerator, and positive things are in these two quadrants that we've got here. So that is going to be H. Now, our last one is a cubic graph. Well, that's not cubic. None of these here are cubic. That's a quadratic, that's quadratic. I think this is going to have to be the cubic one that we've got here because it's got that kind of wiggle that a cubic has. So we've got CFAH. So I'm just trying to kind of explain my logic as I go through these ones that we've got here. Okay, now, even though this could have gone in the proportion topic, I decided to put it in types of graph because I just think it kind of belongs here because of the shapes that we've got. So it says that the graphs of y against x represent 4 different types of proportionality. Match them to the graphs. Now, these like little symbols, you could actually just replace all of these with equal signs and say that it was just like y equals x, or y equals x squared, or y equals the square root of x. And our last one, y equals 1 of x. Normally we would say it was like y equals kx, but I'm just saying like here, it doesn't matter if k is equal to 1, let's just say what the graph shape is. So first of all, y equals x is going to look like graph B, it's just the straight line. Now the x squared one is like, if you imagine this as a whole graph, this is the one that looks like x squared, so it's going to be D. Now the square root of x and the reciprocal one, I think it's easier to tell that this is the reciprocal one, because we also saw it on this previous one, like this is the reciprocal, so look at that shape that we've got there, and that's also talking about the inverse proportion. So that one's going to be C, which means that this one here is A, this is the square root one, so we get BD AC. Now they love these questions, there's loads of these. So we want to talk about some of these other things about f of x here. It says match each graph, match each description to the one of its graph. So I think probably the easiest one to spot is the trigonometric one. I think a is going to be the trigonometric function. And then it says that f of x is an exponential function. Well, that's d. These two have got like really unique shapes that we've got here. And then we've got the one which is inverse proportion and the one which is directly proportional. Well, remember, inversely proportional meant that y equals 1 over x, which we know is a reciprocal graph, so that must be b. And being directly proportional to the square root of x, that is going to look like c, which is actually just the same one that we were looking at on the previous page. So we've got BADC, and there is BADC. We've got more of these matchings coming on here. So it says, write down the letter of the graph that could have the equation y equals x cubed. Well, it would be a choice of these two cubics, but it's actually going to be this one because you wouldn't get a negative value for positive values of x unless there was something extra going on. So it's just going to be f, and then the reciprocal graph, 1 over f, is just going to be d. If it was this one, that would be minus 1 over f because it's in the negative 2 bits. It had like a negative almost gradient, but well, things that go like this have a negative gradient. Obviously, this doesn't have a negative gradient. So we've got f and d. Got a few more to match. So they love asking about this. You better learn these. That one's the reciprocal graph, which is y equals 1 over x. We've then got y equals minus x cubed and x cubed. Well, we've got to decide between these. Clearly, this one has got a positive kind of gradient. It's going uphill, so that one goes with the positive one. The other one has a negative because it's coming downhill, so that is b. And then the y equals x squared graph is just going to be d. You should be very familiar with that shape. So it's b, c, d, a. This time they want us to do some sketching, so it says show that y is directly proportional to x. They just need to have a straight line like that, and it should be going to the origin, so I'll do that here. And then inversely proportional, that means that y equals k over x, or we could just think of it as y equals 1 over x. So it's a reciprocal graph that just looks like this. Now, I'm really bad at drawing these smoothly. They always seem to have a shake in them, but that kind of shape is what we're looking for this one. So mine doesn't look exactly like that, but I guarantee that would be giving you the marks as well. And that's everything to do with nonlinear graphs. On the next video, I'm going to be solving equations with graphs. We did a little bit of that in the quadratic one previously, but they do get a little bit trickier in that next set of them. If you're finding these helpful, please do share it with your friends. Do make sure you're subscribed to my channel. It really does help other people come across it as well. Thank you.